Hello everybody. This is lesson 7 of the lecture Macroeconomics. I will discuss the slides 66 to 79 of chapter 2, the long-run development of economies. I will discuss in this lesson various policy recommendations, also called policy doctrines, how to deal with the problem of exhaustible resources, which we have analyzed in the last section. I start with the policy doctrine recommended by Robert Solow, the economist who also developed the Solow-Swan model that we have discussed in the beginning of this chapter. Robert Solow received the Nobel Prize in Economics for his theory of economic growth in the year 1987. As one of the leading growth theorists of his time, Solow was confronted with the first Club of Rome report titled "The Limits to Growth" at the beginning of the 1970s. This report was quite pessimistic about the problem of exhaustible resources. For example, it predicted that the reserves for crude oil would run out in 1992, assuming constant exponential economic growth and no findings of new oil reserves. Given this background, Solow proposed his policy doctrine. It is based on a normative and an empirical value judgment. Today, this concept is called very weak sustainability. The empirical value judgment is today called substitution optimism, with a slight derogatory tone in the subtext. According to Solow, it will always be possible to substitute exhaustible resources either by renewable resources or technological progress. So this empirical value judgment is in fact a presumption about the technological future. In an often cited quotation from Solow, this reads, "The world can, in effect, get along without natural resources, so exhaustion is just an event, not a catastrophe." Solow's normative value judgment is the following welfare criterion. The current generation is always entitled to take as much out of the common intertemporal pool as it can, provided only that it leaves behind the possibility that each succeeding generation can be as well off as this one. In other words, this criterion is fulfilled if the current generation leaves enough production factors to all future generations that these generations can realize per capita consumption levels at least as high as the current generation. With a little bit mathematics, it is possible to show that Solow's normative value judgment can be fulfilled if his empirical value judgment is true. The following digression contains the basic arguments. The content of this digression is not relevant for the written examination. Solow's very weak sustainability concept is based on two kinds of value judgments. A normative value judgment or ethical rule according to which the current generation shall leave enough production factors to all future generations, such that these generations can realize at least as high per capita consumption levels as the current generations. This welfare criterion is sometimes also called the max-min criterion. The verb shall in this sentence is quite important because it is the ultimate indicator for a normative value judgment. All normative value judgments can be formulated as a shall sentence. Consider, for example, the 10 commandments like you shall not lie, you shall not steal, and so on. The empirical value judgment is a technological presumption according to which one of the above three sets for enough substitutability between accumulating and exhaustible production factors is always fulfilled. In a couple of research papers, Solo and other economists have developed a formal definition what enough substitutability means. The digression on slide 69 explains the basic idea. These type of value judgments are debatable. This means there is no logical necessity to accept them. It is possible to state a couple of pros and cons for the normative value judgment. For example, one can make an argument for discounting the utility of future generations. One can argue that there exists always a certain probability of large catastrophes, like, let's say, the impact of a meteor or a period of extreme volcanic eruptions, devastating pandemic viruses, or a nuclear war. All of these catastrophes would extinct humanity. Applying standard statistics in this case would imply to discount the utility of all future generations by the probability of such a catastrophe. As a result of this discounting, the consumption of future generations receives a lower weight in maximizing the total utility of all generations. One can of course also make an opposite argument. For example, many parents would not hesitate to state that their children should have better lives than themselves. This would imply that more production factors should be left for future generations such that they can have a higher per capita consumption level. A different point of view would also be a non-anthropocentric standpoint. According to this, not only the interest of the human population, present or future, should be respected, but also the interests of non-human species or even whole ecological systems. We will come back to these type of normative standpoints. In a similar way, pros and cons can also be stated for the empirical value judgment of Solo. Whether there is enough substitutability or not depends on how one evaluates the future relationship between exhaustible resources and renewable resources and the potential for technological progress. So here we do not talk about simple facts, but about assumptions for the probability distributions of future facts. Therefore, there is not a scientific necessity to share Solow's substitution optimism. There's, however, one interesting point about Solow's sometimes derided substitutability optimism. We know today, indeed, a couple of technologies to substitute fossil energy like crude oil by renewable energy like solar energy. So we have indeed already found technological substitutes for fossil energies. The only problem is that these alternatives are currently more expensive than fossil energies. But this may change in the future, either by further technological progress or by environmental protection taxes which charge the environmental pollution costs of fossil energies on their usage. In the following, a couple of well-known alternative point of views are surveyed. Solow's early sustainability concept has provoked a couple of alternative proposals for sustainability concepts. Three well-known alternative doctrines are therefore explained in the following. This table distinguishes between various sustainability concepts according to their characteristic ethical or normative value judgment and empirical value judgment and the resulting policy conclusion. In the first row, the concept of Solow is described. Very weak sustainability. As we have already seen, his ethical value judgment is future generations should be able to consume at least as much as the current generation. The empirical value judgment is it will be possible in the long run to substitute all exhaustible resources either by other resources or by technological knowledge. The economic policy conclusion resulting from these assumptions is no government intervention is necessary. The market mechanism is able to solve the problem of intertemporal resource allocation in an efficient way. So far, a short repetition of Solow's sustainability concept. In the second row now, the concept of the so-called London School, which is also called weak sustainability, is displayed. This concept shares the ethical value judgment of Solow, but not his empirical value judgment. Instead, it is based on the assumption that a complete substitution of all exhaustible resources by other production factors is most likely not possible. Therefore, it comes to the economic policy conclusion: it is necessary to respect minimum limits for exhaustible resources and the regeneration limits of renewable resources as far as necessary for the survival of the human population. The sustainability concepts discussed so far, very weak sustainability and weak sustainability, share also an implicit normative value judgment. They both care only for the welfare of the human species. From this normative position, other species or ecological systems are only insofar of any importance if they are necessary to support human welfare. They are no ends in themselves. This normative judgment is called anthropocentric. Anthropocentric. Because humans are in the center of interest. The next two sustainability concepts do not share this point of view. These concepts are called biocentric. In the first row of this table, the strong sustainability concept is outlined. This concept relies on the ethical value judgment that the stock of natural capital shall be kept constant quantitatively, no matter how high the opportunity costs in terms of foregone human consumption are. The stock of natural capital is defined as natural resources plus ecological systems. This concept makes no specific assumptions with respect to substitutability of exhaustible production factors. Whether exhaustible resources are substitutable or not is of no importance, since human consumption has to adjust to the premise of keeping the stock of natural capital constant. The economic policy conclusion is economic growth is only allowed for if there is enough technological progress that permits an increase of GDP without reducing the stock of natural capital. The sustainability concept in the second row is called critical sustainability. It shares the same value judgment as strong sustainability with respect to the stock of natural capital. It is, however, based on the empirical value judgment that economic growth produces so much unwanted byproducts in terms of environmental pollution that it must be prohibited. The economic policy conclusion from this assumption is that GDP growth must be prevented. To avoid a permanently shrinking GDP per capita, population growth has to prevent it also. This overview of different sustainability concepts spans a large bandwidth of different positions. It is, however, far from complete. Everybody is therefore invited to find her or his own political standpoint in this debate. So much for this lesson. In the next lesson, we will discuss how we can explain long-run changes in the composition of GDP, a phenomenon called structural change.